Good afternoon and welcome to EV webinar number 1, Charging at Home and Away, presented by Lincoln Electric System. I'm Marc Shkolnick, Manager of Energy Services, and I'd like to thank you for sharing part of your day with us, learning about and discussing electric vehicles. Before developing this 4-part EV webinar series, we sought input from customers, and among the highest rated topics was charging. Today we are going to take a deep dive into home and public charging. But before I introduce our guest presenter, let's go over a few housekeeping details. You are in view-only and listen-only mode, so our main form of interaction will be using the Q&A box, which is located at the bottom of your screen. We'll go into that in just a second. We encourage you to post questions as you think of them. We do have a Q&A period that we look forward to having good interaction following our presentation today. This webinar is being recorded and will be available on our website in the next couple of days if you'd like to go back and review it and get more information as you do that. In terms of using the Q&A feature in Zoom, you'll notice at the bottom of your screen there's a toolbar that appears. You'll want to use the Q&A and click on the Q&A box. When you do that, you'll get a window that'll open. You just simply put in your question, type it in there, hit send, and we will get the question. And we will get to those questions at the Q&A period, which will follow our presentation. Before we begin today, I'm going to ask a couple of questions of everybody who is participating today by virtue of a couple of polling questions. So here they are, and you should be able to answer. Question number 1 is, what level charger do you have at home? A level 1, a level 2, don't have access to a home charger, or other. And your second poll question is, what type of electric vehicle do you currently drive? Battery electric vehicle, plug-in hybrid electric vehicle, or an internal combustion engine vehicle, a non-plug-in. And I'll give you just a few seconds to vote. We have a little over half of the folks who've already registered to vote. And in this poll, we still have a few more seconds to let you to respond, and I'll share the results here in just a moment. Somebody asked if you have an EV and an ICE vehicle. Well, I think that you're just going to have to make a difficult decision. All right, let's see what we got here. Let's share the results. We've got about a third, a little over a third, have level 1 charging at home, another third with level 2, and about 25% do not have access to a home charger. So that's kind of where things stand with our cohorts today on charging at home. In terms of the type of electric vehicles that our participants drive, we've got a little under half have all electric, battery electric vehicles. A little less than a third have plug-in hybrids. And we've got a few folks who are obviously interested in electric vehicles, but they're currently driving internal combustion vehicles. The other I could only assume would be horse and buggy or some other type of transportation, which this did not cover. So thank you for sharing your feedback on these polls. Now I'm really delighted to introduce our guest speaker for today. John Halliwell is a team member in the Electric Transportation Group at the Electric Power Research Institute, EPRI, where his focus is smart charging and infrastructure development for plug-in electric vehicles. He joined EPRI in 2007 and has been active in the electric transportation space since 2008. He received both Bachelor of Science and Master of Science degrees in electrical engineering from the University of Tennessee and has broad experience in design and application of electronic circuits and electronic systems. His favorite pastimes are hiking, building, and repairing tube guitar amplifiers and amateur radio. With that, I'd like to turn things over to John Halliwell.
Thank you very much, Marc. I'll go ahead and get my slides up here and we'll get started. I'm going to jump right in. So it looks like the majority of our listeners have EVs. That's a good thing. But I'll talk a little bit about, what's unique about fueling an electric vehicle. And I think there are two key things. One is you can refuel your vehicle at home, and that I have a gas can being silly with my Leaf, but if you could bring gasoline home to fuel your car, but it's not a very convenient thing. But I can plug my electric car in, and the charger you can see over my right shoulder there, and charge my car at night at home. And that's very unique to an EV that you can fuel at home. The other thing is how fast you charge. That's particularly true for an electric vehicle. If you have a gas vehicle, you don't think much about the time.
But you can share it off your OneDrive. You have to play with it.
If you could please, let's have everybody mute their lines. It looks like we have a little bit of background noise there.
I'll try to continue there. So,
Yes,
so the
go
other thing
ahead.
that the other thing is that how fast you charge matters.
Yeah, I don't remember off.
Unlike a gasoline vehicle where the time you spend at the pump really is like the flow rate. You don't really pay anything different. It doesn't really take different equipment. Whereas in electric charging, it takes different equipment to achieve these different charge rates, and we'll talk more about that. So quick word on power and energy. I'm an electrical engineer, so this is pretty familiar to me, but I think for a lot of consumers, you're used to thinking about gasoline in terms of gallons. It's not really an energy unit, but we do kind of relate that to how far it carries our car. When we talk about electric vehicles, then we talk about power and energy in terms of kilowatts and kilowatt hours. Just to give you an idea of how much energy is in a kilowatt hour, an adult diet is 2,000 kilocalories, and that's about 2.32 kilowatt hours. So your body, the heat, the energy your body uses in a day is a little over 2 kilowatt hours. Interestingly, that would carry a vehicle like the Nissan Leaf, takes about 0.3 kilowatt hours per mile. So that would carry that vehicle, is that almost 10 miles? It's like 12 or 15 miles. So that gives you an idea of how much energy is in a kilowatt hour. It's also, if you ran a 1,000-watt hairdryer for 1 hour, that would be a kilowatt hour. And so it's just a product of power and time. And so again, in EV space, we talk kilowatts. Technically, you can use megajoules. I don't know that anybody will do that, but that is allowed in this standards for how you publish out energy to consumers. But hopefully we'll stay with kilowatt hours just to be consistent. And just as a note of information, that 28% of the energy consumption in the US goes to goods and people movement. And that was 2018 numbers. So how hard is it to charge? I think it looked like the majority of you have EVs, so you know this is pretty simple. It's designed to be intrinsically safe. Industry standards have been written to make sure charging is safe, that the cable's not energized until plugged in. Can you damage your battery if you're careless? You can't overcharge the car. The vehicle's battery management system is not going to let you do that. What about over discharging the battery? Can I run it too low? The answer there is no. For those of you who have done this experiment, your vehicle does have some ways it warns you that you're about to run out of charge. If it's an EV only, a battery electric vehicle where that's your only fuel source, they tend to have a lot of screens that say you're getting close. My boss maintains you're not a brave EV driver if you haven't run your car completely out of charge, but it does not damage the battery to do that. The vehicle's battery management system, again, protects the vehicle. And how you charge, will that damage your battery or shorten the life? So if you use DC fast chargers frequently. With our current generation of vehicles, that is not the case. Automakers are designing cars to meet their warranty requirements and pretty much independent of your charging behavior. And that caveat is there were some early vehicles in the market with smaller batteries that you've probably seen press about that may have some impacts, but as vehicles get into the 60 kilowatt hour range on their batteries, where they have almost 200, 250 miles of range, that doesn't seem to be an issue from the data that we've seen. And this is based on proper design. So the battery management system is designed and built to protect your battery, to keep it safe throughout the life of the vehicle. So the big question a lot of people ask is, how long will it take me to charge my vehicle? And so it takes a little bit to answer that, so I want to spend some time. So first of all, again, energy is the product of power and time. So when you look at these three curves I've drawn, if I drew those correctly by hand, each of those represents about the same amount of energy. The lowest curve is a low power charging session. That could be similar to using the level 1 cord set that came with the vehicle. The medium curve would be using, say, a public level 2 AC charger. And then the top one would be something you'd use a fast charger where you're away. So home and away, you can use both of those lower levels. You can use your cord set at 120 volts, or you can use a public charger. They're typically rated for about 7 kilowatts. Those can serve you at home and away. It depends on how long you're going to be at an away location. If you're going to be somewhere for a few hours, then those are appropriate. For the techies in our audience, these are the power levels represented and the types of charging that can occur with those standards. AC level 1 being the bottom there, up to a couple kilowatts. AC level 2 and wireless charging will support up to 20 kilowatts roughly. And then DC fast charging, we're now seeing systems that can go up to 350 kilowatts. So back to that question again, how long will it take you to charge? So I would ask you a question, how far have you driven? Because you only need to fill the portion of the battery that you've used since your last charge session. So that's a key thing. The other question I ask people is, how long does it take to charge your cell phone? And most of us don't know because it happens overnight when we're not looking at it. An EV, if you use it for daily commuter car, that's pretty much how they work. You plug them in at night and they're ready to go in the morning. But if you're concerned about going on a road trip, you want to go to the next city, then this question does matter because you want to know how long you're going to have to stop along the way. So a typical EV goes about 3 1/3 miles on a kilowatt hour. If you've driven 20 miles since your last charge, that's a little bit less than what I drive in my daily commute when I was allowed to commute. I'm working from home these days. So in that case, I used about 6 kilowatt hours to make my trip. And on a typical 7 kilowatt AC charger like I have at home, it takes about 1 hour to replenish that driving. If you've driven 100 miles since your last charge, then you are going to be replacing 30 kilowatt hours. Typical 7 kilowatt charger, that's going to take about 4.5 hours. A 50 kilowatt fast charger could do that in about 30 minutes. And so the charge times vary depending on what size technology you have in terms of like your onboard vehicle charger has a power limitation and the charging equipment that you're connected to. So sort of the least common, the lowest power capacity is what will determine how fast your vehicle charges. And there are 3 methods of charging vehicles. You can use AC current, which is typically done at home on the level 2 or level 1 AC chargers or the cord set that comes with the vehicle. Wireless charging will become an option soon. There's been some pilots done with that and a small number of lease vehicles with wireless charging. And then away from home, typically you're going to be using DC. So AC is alternating current, DC is direct current. DC is what the battery on the vehicle operates with. And normally on board your vehicle, there's a conversion from AC to DC. On those home systems, on the wireless system, you're using high frequency AC. And then the DC system, the power electronics now are off board the vehicle and you provide DC power to the vehicle. So when you look at examples of AC equipment on the right, or I'm sorry, on the left side of the photo, those are level 1 cord sets. That's typical of what comes with your vehicle in the hatchback or the trunk of the car. On the right side, those are pictures of some public chargers. Those also could be used at home. The one on the far right there, those little circular chargers, those could be mounted on the garage wall in your house or outside your driveway. You saw my charge station in the first photo is actually mounted on a post next to my driveway. I don't have a garage. But the AC charging systems vary in size. Typically, home units are small, and they generally are made of plastic. Many of the public chargers, like the unit there sort of near the center, are made of metal, and they're fairly large, partly just so you can see them there, so you can find them, say, in a parking garage. And you may see units that have cable management, like the center picture over there under the level 2 AC, or you may see them where the cable hangs on a hook. That's the variations. How about home charging? So home charging, do you need to upgrade your electric service? The answer to that is maybe. There are differences in different parts of the US as to the typical size of electric service on homes. Here in the Southeast where I live in Tennessee, the typical service size in a home is about 200 amps. And so it can support a charger typically unless you have a lot of other things going on in your house, that a charger is not a challenge. In my case, you can see the photo there. I actually had to have my service meter, the location where the utility meter is, I had to have that box replaced, and then have the pedestal or the post installed, a little bit of trenching. All those things cost money. The distance from where your electric service is to where you park, that's one of the critical parameters in understanding how much this might cost. The best thing if you're not a technical person, you know, hire an electrician, have them come out and give you an estimate. And I recommend you do that with more than one electrician so you can make sure their estimates make sense. The typical costs vary quite a bit. And so down at the bottom, I pulled some data. Vista Corporation up in the Pacific Northwest had a pilot program where they deployed charging to their customers. And you can see there that's over the non-network would be what would be typical for your home. They did 113 installs, and average there was, you know, was about $1,700 altogether. That's including the charge station cost. I think in my case, my cost was a little bit higher, but I also had an RV outlet put in when I had this work done. So that will vary. So again, you probably do need to have your home electric service looked at. If you live in an apartment house, a multi-unit dwelling, you probably need to talk to your apartment management. That can be tricky, and that you know, working with them, trying to understand how you might be able to charge a vehicle at that location. Wireless charging, it's coming. The standard in SAE, the organization that does many of the standards that are used for electric or even gasoline vehicles, that standard was approved about a year ago. BMW did a pilot in California with 200 lease vehicles. I'm suspecting that next year you might start seeing the wireless charging becoming an option offered for vehicles that come off the lot. And that's a photo I took at a trade show there. Qualcomm is one of the companies that makes equipment, and you can see a BMW vehicle demonstrating how to wirelessly charge. It's in a sense a pad that goes, a rectangular pad that goes on the floor of your garage, and you pull the car over top of that pad to charge. The last method of charging is DC charging. Unfortunately, the industry didn't get their act together and come up with one standard here. So we have 3 interfaces that are out in the public. I did notice today that I think Nissan made an announcement that they're going to start using the combo connector going forward, starting, I believe, in 2021. That's sometimes referred to as DC level 2. Unfortunately, some people call it level 3 charging. That by the SAE standard, that's not defined, but you will hear it called that for DC fast charging. And again, these interfaces allow you to couple to the vehicle using DC current. These units typically are much larger physically. They may contain the power electronics in the unit where the cables are. So the unit on the far left is an example of a piece of equipment where the power electronics are combined in with the dispenser. If you've seen a Tesla charger, it's the little loop-shaped hole in the middle there with Tesla logo, second picture from the left. In their case, they have the power electronics remotely located in separate cabinets, so that is only a dispenser. The tan color charger there is one that also has the electronics locally. And then these are dispensers on the right there. You may be familiar. So this is EVgo, Tesla, FSEC, and Electrify America charging locations. Each of these units that I've shown, except the Tesla unit, you can see that they have 2 different cables. That is because the units carry both the combo cable, the SAE combined coupler system, and the CHAdeMO port. So they will service vehicles that have either type of connector. Tesla does offer an adapter that allows Tesla drivers to use CHAdeMO. They do not currently offer an adapter in the US for the combination coupler, but I know they have one in Europe. I guess the other thing is that at public chargers, the DC fast charging locations, many right now are like the one at far left was a single unit at a location, but we're seeing more and more locations similar to what Electrify America is doing on the right. I didn't take a picture of one, but where you'll see multiple posts. And Tesla has done this from the get-go at their supercharger stations. They'll have generally at least 4, but oftentimes 8 or more cables. And that is mostly to support having multiple cars at the site at the same time, and to control not having the long lines of vehicles waiting. So we're probably going to see more of that as we go forward, charge sites that have more chargers localized like that. So to summarize, there are a lot of options for charging an electric vehicle, both in location and power level. And what you choose a lot of times depends on your driving needs and what you're doing. I use my electric vehicle as a commuter vehicle, so I drive it from my home location to work and back home. I typically don't use public charging. I use my level 2 charger here at home and have done that for quite a while. I think I've actually only used public chargers about 3 times, and that was mostly just to see what the experience was like. Some of you may use the vehicle very differently, and you rely totally on public charging. So that, again, there are a lot of those options with electric vehicles. One thing to keep in mind with an electric vehicle that using lower power levels will cost less. You know, both the equipment and oftentimes the cost of the electricity is lower at a lower power level. This is particularly true for the DC fast chargers. So a public DC fast charger will probably charge a higher price than a public AC level 2 charger running at a lower power level. So the longer you have to charge, the lower power you need to get the energy into the vehicle, the more likely you can take advantage of lower power charging means, and it probably will cost you less. And again, that's very different than gasoline. Again, there are roughly 3 power ranges that are out there. There's the slow, like level 1 systems, level 2 AC, medium, and then DC for fast charging. And there are 3 types of charging: AC charging, DC charging, and wireless. And finally, there are 3 types of DC charging interfaces. So you can start thinking that there's a pretty big matrix here with 3 speeds and 3 types and 3 interfaces. So lots of variety in charging. So I'll stop there, open up for questions and comments, and if you want to drill into something more detailed, I'd be happy to do that.
So, thank you, John. That was terrific and good information for everybody here. And we actually have a few questions, John, and we'll kind of go through these as they came in. I got a question here. It says, I drive a plug-in hybrid. In the summer, it will charge up to 28 to 32 miles. And the question is, using LES rates, how much does that cost to charge from empty to 30? And I was doing the math real quickly in my head.
Yeah, so I'm getting my calculator here.
Yeah, I'm thinking if you're getting, let's just say you're getting 3.5 miles per kilowatt hour, based on our seasonally weighted average, we're probably looking at about 70 cents. You know, you figure, and again, you know, if you're driving a lot in town, you may get a little better than 3.5 miles. If you're driving without regenerative braking, it may be a little less, but around 70 cents, I think.
And that's probably a good place to make this point. So I know it's a figure that DOE had put out a while back, and I think it's still pretty applicable, that in the ballpark, electric driving is roughly the cost of $1 a gallon gas, and there it was about 70 cents to go 30 miles. So that's a 25 mile per gallon car. You know, be roughly $1 a gallon is kind of
yeah, exactly. The next question is about costs for level 2 in new home construction. I guess a lot of that is dependent on a variety of variables. I know, Jennifer, see if I can. Let me see if I can unmute you, Jennifer. Let's see here, because we had.
While you're doing that, Mark, I'll just make the comment that, you know, that it's certainly going to be lower cost because you're doing it new. You can do this with an outlet, so you can have the electrician install a 240 volt outlet, because there are chargers now available that can be plugged into an outlet and mounted to a wall. In that case, instead of being, you know, on the ballpark of $1,200 or $1,500, you're probably talking closer to maybe $100 or $200 to add that capability. And again, it's really the cost of some wire and an outlet, but it is site dependent. You know, if you have to go from one end of the house to the other. You know.
You want to add anything to that?
Add to that?
Yeah. I don't know if I'm unmuted.
I'll mute mine.
We can hear you.
Can you hear me okay?
Yes, ma'am.
Okay. So last winter, we put in a 240 volt outlet in our garage, and our panel was already big enough in our house. Granted, it's not new construction, it's existing. However, our panel was big enough, we didn't have that added expense. So I would assume that our panel was big enough, the cost would be very similar to new construction. And just running the wire itself, I don't know the specific footage on it, but I do know the cable itself was the biggest expense. And just running the wire and labor was around $800 to $1,000. So I would expect that would be probably what new construction would be as well.
I would guess it'll be a little less because it tends to be done as part of the install. So one of the issues that you have to understand is, like an electrician coming out to your house, they have sort of a base fee because they have to roll their truck. So having them already wiring your house, that's the one advantage you'll gain. So it's probably the biggest difference would be not so much the labor hours, but the fact that they're already on site doing work. So that is a cost savings for them because they're doing a larger job.
So I've got a question here about the Tesla superchargers, and the question is there any future in which non-Tesla customers will be able to go to a Tesla charging station with an adapter and use those public charging stations? Do you envision that happening based on what you know, John?
I mean, adapters are always challenging. I mean, as an engineer, I'm not a big fan of adapters. Particularly, we're talking about fairly high power levels here, where you're working with 50 or 100 kilowatt type electrical systems. So I'm not a big fan of adapters just from a safety perspective. I think it's better to have the native parts connected together directly. Having said that, it really comes down to what Tesla decides as a business decision. There are differences in how Tesla controls their charger. In the case of CHAdeMO, I think it's a little easier lift because CHAdeMO uses the same technology to do their communications for charging. The combo coupler system uses a different technology for the charging control communication, so there's more circuitry required to make that transition. First of all, I guess you need available adapters, so somebody has to step up and design and make that, and then Tesla would have to open it up because it is a system that is owned and controlled by them. So I don't really have an insight into whether that will happen or not. It's really a Tesla question. And I would assume as long as it's to their advantage not to do that, they probably wouldn't.
Okay. If you happen to join us a little bit late, we invite you to submit questions using the Q&A box at the bottom of your screen, and we will take those as they come. Just go ahead and submit those. I do have a couple of questions, John. One is a situation that we ran into with our electric vehicle. Of course, we had the pandemic, and the vehicle that we use in our fleet, our all-electric vehicle, sat for about 3.5 months. Didn't have extreme weather. It was plugged into the level 2 station over in a parking garage, and we came back to find that the vehicle was deader than a doornail. And that seems odd. You've got this vehicle. It's got probably a 60 kilowatt hour battery, and you wouldn't expect you'd ever have a problem opening the door, getting in, and starting it up. And so you want to share the insights there as to what happened, and something that maybe some of the folks who's participating today may have run into this as well.
Yeah, so it's something that we learned pretty early on in EPRI because we do a lot of testing. So we have vehicles in our lab area that we frequently don't use for a long period of time, and so we would run into this. It really comes down to two things. So one, the electric vehicle isolates the high voltage battery when it's not operating. So whenever the vehicle's not in use, when you key the vehicle off, there's a contactor that opens that's embedded inside the battery pack. And the goal of this is to keep high voltage DC as contained as you can inside the vehicle, so it's not on the other vehicle systems. So from a safety perspective, that battery is isolated. So that means there's a 12-volt battery, just like your conventional internal combustion car. There's a 12-volt lead acid battery under the hood, or in the trunk, or under the seat, somewhere in the car. That battery is used to maintain things like the airbag system and alarm systems. And there's a challenge for automakers. When the car is sitting idle, you can't always draw lots of power from that 12-volt battery, or you will discharge it down to the point where it's non-functional. And so for some of the EVs, they keep that high voltage battery isolated, so they're not available. The high voltage battery is not available to provide any power, and that 12-volt battery is there being used to operate the systems. If the car sits for a long time, the challenge automakers have is they have to let the vehicle sleep. They can't keep things awake and operating all the time. And so if you leave a car long enough, generally they're good for probably 4 to 6 weeks. I think the industry tries to allow it to, the battery draw is limited such that the lead acid battery will last for weeks sitting idle. I think I've gone as long as 3 weeks on a car without any issues. But when you get out to like a couple months, you're starting to get a challenge where you may actually deplete the lead acid battery. Unfortunately, you can't wake up the charge system at that point. So there's no way for the charger, even plugging in a charger to the car at the high voltage charging port, will not make the vehicle work because the systems on the vehicle aren't able to power up. One option for manufacturers is to wake the vehicle up at intervals and see if there's AC current is available and actually go back on charge. But to my knowledge, most vehicles don't do that. They sleep, they're powered off, and therefore the 12-volt battery is all that's there to sustain the vehicle.
And I would imagine that extreme ambient air temperatures would even make the situation worse for the lead acid battery, or would it maybe not necessarily be as
Probably not so
impactful?
much heat as cold. I think in the
Okay,
here
sure.
you're gonna take more of a toll on the 12-volt lead acid battery. And the other thing is in electric vehicles, if it's a battery electric vehicle, it does not have a starter motor. So there's no need for a large lead acid battery. So the automakers, in order to reduce weight of EVs, have shrunk the lead acid battery down. And if you look, many of them have what looks like a motorcycle battery because all they're having to power is the electronics. And so they've gone to a smaller battery, so it probably has less reserve in terms of sitting for 20.
So that exasperates that issue of idle time. And certainly if you're not driving the vehicle, and we obviously weren't driving the vehicle for more than a couple of months, then that's kind of what we've dealt with in that situation.
In that case, if you'd gone out and just powered the vehicle
Yeah,
once, every 4 or 5 weeks and let it sit for just a few minutes, that would probably
generate. Yeah, okay. Questions just come in. Are we billed for the time we spend at the charger instead of the amount of electricity downloaded? So there are public chargers that if you're not charging but you're plugged in, particularly in the DC fast charging, you do get charged up, and it's to incent you to get off that and not occupy idly. Do you want to comment on that, John, about?
Sure. In your territory, is sale of electricity done by kilowatt hours, or are charging companies selling time at this point?
Right. So our regulations require that only utilities can sell by the kilowatt hour. So we have, for example, the Electrify America superchargers that we have in town. I believe it's 35 cents a minute while charging, but 45 cents a minute while connected but not charging.
Yeah, and so what we've seen in the industry, it varies. It varies across stations. You know, certainly that's one of the things from the consumer perspective that the industry is going to have to work on to improve. And there are certainly regulations coming down in the future that will impact this. But having clear statement on a charger as to exactly what you're going to pay and for what items. So there, some chargers have a connection fee. So there may be a flat fee for plugging
Right.
in. There may be a fee for parking. If you're in a parking garage, they may charge you for the parking. And then there may be a time fee or a kilowatt hour fee for the energy. Certainly charging for energy is probably the clearest way to make sure that what you get, you're paying for what you get. The time is also an alternate, but again, as the person asked, the fee may be flat the whole time you're plugged in. Most systems, I do believe, charge the entire time you're plugged in. They're not just charging for the time you're actually getting energy. So, but that's look at the systems and make sure you understand what's there in the public.
We have a question about North Star High School. Is the charger there a DC fast charger? Well, I know it's not a DC fast charger. It's a level 2. I didn't even know there was a level 2 at North Star, but evidently there is. So that would be like most of the chargers around town. In fact, the only DC fast chargers currently is the Tesla superchargers up on North 27th at the Hy-Vee, and those are for Tesla vehicles only. And then the Electrify America stations that went in about a year or so ago, that is up at, I think, Northwest 20th Street at the Casey's near the interstate. However, we do have more public infrastructure coming thanks to the generous support of the VDOT Development Funds and the Nebraska Department of Environment and Energy. There was rebates provided to commercial customers to install public charging infrastructure, and LPS plans to put in level 2 charging, public charging stations at most, if not all, of the high schools around town and their operations building near Lincoln High School. And then I know B&R Stores has, I believe, 3 locations. And I believe those will be DC fast chargers. So along Highway 2, up in Fallbrook, and also out in Waverly, which is just off the interstate. I know there's another location in Central Lincoln that'll be a level 2 at an auto care center. And then, am I overlooking anything? Oh yes, the University of Nebraska Lincoln, I believe, has 3 sites on city campus for level 2s. These will be their first charging stations, and then Innovation Campus will actually have a DC fast charger and a level 2 available at the hotel and conference center they're building to construct. So that will dramatically increase charging stations in areas of town that currently aren't served. But we've known from our research, and next Monday we'll get into some of that deep research that we've done on EV charging at home. We know that a vast majority of folks in Lincoln at least charge at home, but for people who are coming from out of town, this is a real good amenity to have. The chargers at the public parking lot here in Lincoln charge $1 an hour. That's right, when charging, and 10 cents an hour after that. Thank you for offering that. Our level 2 stations are priced in that range. We have a couple of charging stations that LES operates. They're basically $1, I believe $1 an hour is what the charge is. So. And then I have another comment or question here. My original Leaf indicated that if you left the car sitting for a long time, it should be unplugged. My new Leaf, which is a 2019, doesn't indicate either way. Is there a right way? John, any thoughts?
I would suggest leaving one plugged in. Some of the vehicles, and the Leaf may be an exception there. I have a Leaf, actually, is what I drive. But some of the vehicles will wake up if they're plugged in and will maintain their battery system. They can cool or warm the batteries. So having them plugged in does give the vehicle more freedom to take advantage of that connection if it wants to. So leaving it plugged in, I'm not sure. There's really no downside to leaving it plugged in. Typically here at home, if our car is home, it's plugged in. And that way, like I say, the other thing is that if you have a phone, many of them have apps, like a phone app, where you can pre-cool or preheat your car in the morning, or if you're at work.
It's plugged in.
Yeah, so if it's plugged in, you can take advantage of that without hurting the range of your vehicle. So that's another reason you might want to leave it plugged in.
I don't see any questions pending, but I did have one here maybe to pose to you as we wrap it up. And that is, John, what do you see the greatest advances in charging technology being in the next 5 years or so? If you think about home charging or public charging infrastructure, where do you see the greatest advances taking place?
Okay. I think in terms of if you're into convenience, when I looked at this, I didn't see a big need for it, but wireless charging may be of interest for someone at home, particularly if you have a garage. I don't have a garage, but if you have a garage, a home wireless charger may be of interest. Certainly in 5 years, those will be out there and available. I don't know if we'll see public wireless charging. That's more of a challenge because all the vehicles on the road right now can't take advantage of that. Higher power levels at DC chargers, that certainly is being established. Keep in mind that many of the vehicles being sold now can't take advantage of some of the power capacities that are available at charge sites. So it's a combination of what the vehicle can handle and the charge site. But I think probably the biggest thing though is just the number of chargers in public. I think you're going to see an increase in numbers. Right now there are map apps that you can go look at to find where the chargers are located. Typically, I don't do that for gas stations. When we do have a gas vehicle here that my family has, I don't normally look at maps for gas stations, but I would if I was driving my EV. I think at some point you have enough infrastructure out there that you don't need maps. You kind of know it's going to be available in enough places. We're not there yet, but in 5 years, I'm hoping we're much closer to that just the population of chargers will have increased.
I do have another question here, John, from Bruce, who asks, why do the batteries not charge as much in the winter as they do in the summer? Is there anything I can do to get it to charge, I guess, maybe more efficiently or quickly in the winter as it will in the summer?
I suspect what that is like the vehicle's range indication is smaller in winter. That it's not really charging the battery less. I think it's just the capability of the battery. So cold has two impacts on a battery. One, batteries are a chemical system, and chemical reactions move faster when they're hot and they move slower when they're cold. So the cold does tend to raise the internal resistance. The losses in the battery increase when they're cold. Lithium batteries also require to be maintained in the temperature range. They can't get too cold. There are bad things that can happen to the battery if it goes well below freezing. And there are bad things that can happen to the battery thermally, like thermal runaway if they get too hot. So the battery management system's main job is to maintain the battery in that window. Actually, the vehicle uses more energy in the winter. So if you actually tallied up your kilowatt hours, because you're probably heating the cabin of your vehicle, and because of those internal losses in the battery, the vehicle will actually use more energy in the wintertime than it does in the summer. One variation in that, so some of the newer vehicles now have heat pumps in the vehicles. So they, an air conditioner takes less energy because it's moving heat as opposed to generating heat. So the air conditioners tend to be a little more efficient. You may see, a 10 or 20% reduction in your range. Heating maybe more like 30 or 40%, depending on, and I'm thinking of like some of my vehicle has a much smaller battery. Some of the new vehicles with the larger batteries, it's not as a big impact. It doesn't have as big an impact on the range of the vehicle when you use things like climate controls. And as the vehicle batteries get to where we have, roughly the 300-mile range electric vehicle, I think you'll worry much less about heating and cooling like we have of late. But air conditioning is a little more efficient than resistance heating, but there are cars that have heat pumps. Like I know the new Leaf has a heat pump. So down to somewhere around like the freezing range, it's still not quite as bad as having a giant hairdryer.
John, what's the biggest load then if you think about winter and its load on the battery? Is it the heating system? Is it the thermodynamic impacts on the battery itself? Or is it the thermal system that keeps the battery warm? What's the bigger draw?
One would be the heating system. So the typical vehicle, you're using 2 or 3 kilowatts of heating.
Okay.
Think about a car, it's a metal box. It may have a little bit of insulation.
Right.
It's, I know you guys get cold like we do.
Yes.
So it can be below zero, and that you're literally discharging, a 2 or 3 kilowatt heater almost continuously while you're driving. So if you think about it, that's actually that's probably on par, like an hour of driving with a 3 kilowatt heater. That's almost as much energy is going into the heating as in moving the vehicle. So that's a big significance. Also, if the vehicle has to be warmed, particularly when you first get in the car. So one of the things you might want to do if you live in a cold climate is have the vehicle where it's plugged in and you can preheat the vehicle, or the vehicle can take advantage of being plugged in and preheat the battery before your departure. That will help. The slug of energy it takes to warm that battery up in the morning does impact your range more. So if you can do that from the power grid, then you don't get that range loss.
So combined with what you said and a question I just got about will LES be offering off-peak charging in the future, I'm going to leave that as cliffhangers, because on Monday, we are going to get into that on our EV webinar number 2. And in fact, I want to let everybody know that we have 3 more webinars on electric vehicles. And if you haven't already registered, we've got EV webinar number 2 coming up on Monday at noon as part of our Sustainable Living Festival, which is virtual this year. We'll run all next week, but the next EV webinar will be Monday. And we're going to get into research findings from over a year-long research that we've done with about 85 EV drivers here in town. And some of our findings are really fascinating. They'll inform whether or not we should be offering an off-peak rate. We currently don't, but whether we should consider it in the future. It'll also get into some of what you were talking about, John, is what happens with winter driving. What's the range? What's the energy draw? What's the energy consumption of our EV drivers, and what's going on with that? We get into that on Monday. EV webinar number 2 will be held at the end of Sustainable Living Festival next Friday. That's going to be at noon over the lunch hour, and that's going to be hosted and moderated by Jennifer Bangert. And we have a EPRI presenter who will be talking about what to consider when contemplating a purchase or lease of a plug-in hybrid or an all-electric vehicle. By the way, on Monday, we'll have Scott Benson here at LES, as well as Eric Wood from the National Renewable Energy Labs, discussing our research findings. And then we'll wrap it up in early August with Marc with EPRI, who's going to talk about future innovations in electric transportation. John, I would like to thank you so very much for all of your insight and your thoughts. Been very good. I want to thank everybody who's joined us today, and we hope that you'll be joining us for future webinars as we go through this. Please feel free to forward on the information to family and friends who would like to join in. And one thing I want to stress, please take just about a minute to complete a brief webinar that'll be coming your very, very shortly. Give us an idea of found this a productive use of your time over the lunch hour today, as well as any ideas you have for upcoming topics to discuss during webinars. With that, I bid you a good afternoon, and we look forward to seeing and talking with you all next week during our Sustainable Living Festival online. Take care. Have a good rest of your day.
Thank you, Marc, and thank you, Elias.